So this one says, find the indicated term in each of the following sequences. So they want term 6. So term 1 is still 4. That hasn't changed. Okay? R in this case, though, is term 2 divided by term 1, or term 3 divided by term 2, right? So in this case, I'm going to do term 2 divided by term 1. Negative 12 divided by 4, which is negative 3. Okay? And they want term 6. So what's n? 6. Okay? So we're going to use the formula. The formula was on the previous page. I'll show you what it is. Oops. It's this formula here. Tn equals T1 r to the n minus 1. Tn equals T1 times r to the n minus 1. Okay? And you use this formula when it's geometric. You use the other formula we've been using when it was arithmetic, right? So they want term 6. So term 6 equals term 1, which is 4, and then r, which is negative 3, to the 6 minus 1. The catch is that the exponent is only to the r, okay? The exponent isn't to the t1 as well. You'll do r to that exponent, and then you'll times that by t1. Then you'll multiply that by t1. So we're going to get 4, and then this would technically be negative 3 to the 5. Now, if you punch it into your calculator as negative 3 to the 5, not in brackets, it will tell you it's negative, which is okay. But if you went negative 3 to the 4, not in brackets, it'll tell you it's negative, which is not okay. Because negative 3 to an even exponent is actually a positive number, right? Because negative 3 to the 2 would be negative 3 times negative 3, which would be positive 9. But if you don't put it in brackets in your calculator, it'll actually tell you it's negative 9. Because what your calculator does is it does negative 3 to the 2, that is positive 9. But if you do negative 3 squared like this in your calculator, it'll tell you it's negative 9 because it's actually treating it like this. So you have to remember to put them in brackets is my point if it's a negative. Okay? In this case, you wouldn't get burnt because it's negative 3 to the 5, which is an odd number, which would still give you negative anyways, but it will mess you up on the evens. So what's negative 3 to the 5 in your calculator? How do you type that in? Well, you'll press the negative button if you have the calculator. The negative button is beside the enter. That's the way you do it, yeah. You should always put in brackets, yeah, like this. So you go bracket, negative 3 bracket, right? And then you'll use a little hat symbol if you, it's like below clear. You can use that one if you want. Or you can go get it if you want. That one's full of batteries. But you're going to go bracket, negative 3, bracket to the 5, right? So you get negative 243. And then you're going to times that by 4. And what do you get? Negative 972. So the sixth term in this case is negative 972, which makes sense because geometric often will grow really fast or decay really fast, right? Whereas arithmetic just went up by like 3. So it would take a while to get to a higher number quicker, right? Whereas these ones, you get to a high number fast because you're multiplying by 2, right? So if you say you multiplied by 2, you'd go 2 and then 4 and then 8 and then 16. It starts getting fast. This one you're multiplying by 6, or not 6, by negative 3, sorry. So it's going to go up quickly as well. Okay, so let's look at number 3. Number 3 says find the missing terms. So for number 3, you have blank, 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 56, 112, 224. We don't have to use the formula in this case, right? Because when we have terms side by side, we can find out what r is. And to go to the right, you'd multiply by r. To go to the left, you'd divide by r, right? So let's find out what r is. R is, you can either do 224 divided by 112, or you can do 112 divided by 56, right? You just have to do the latter term divided by the previous. So I'm going to go 224 divided by 112, which is 2. So I'm multiplying by 2 to get to the next one, correct? So to undo that, I'm going to divide by 2. So what's 56 divided by 2? Divided by 2? Divided by 2? Yeah. Now B is a little more complicated because I don't have any two numbers side by side, correct? I have 20, blank, 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 320. So I don't actually have any numbers side by side, so I can't find R that way. I can find R though. How would I have to do it? Use that formula, yes. So 20 is what? T1. And 320 is? Tn, or T what in this case? T5. So N is what? 5. So the only thing we're missing is R, so we'll be able to find it. So we're going to go Tn equals T1 and then times R to the n minus 1, and we fill in what we know. So Tn is T5, which is 320. T1 is 20. And we multiply that by R to the 5 minus 1. Now remember, these are attached only to the R. The exponent is only to the R. It's not to the first number, correct? So we actually, the very first thing we're going to have to do is divide that 20 over. So we divide by 20. What's 320 divided by 20? 16? So 16 equals R to the 4. R to the 4. How do we get rid of that exponent of 4? If it was squared, we'd square root it. So if it was 4, we're going to fourth root it. Now, if you want to know where that is in your calculator, I need to upload my calculator back to the screen because normally I can pull it up, but I can't right now. So what you're going to do is you're going to press 4. You're going to press the number 4, and then you're going to press the math button. So 4, and then math. And then you're going to go down to number 5, which has the x in the square root spot. So you're actually putting 4 in that x spot. That's what you're telling it to do. Yeah, and then hit enter. And now put in 16. And hit enter. And what do you get? 2. You go 4, then press math. You have to press 4 first. Did you press 4? No. No, clear. Press 4, math. Then you go down to this one because you're putting it in for the x. And then put in 16. So that's the fourth root. So that 4 you press first actually just gets, like you're picking 4 and then you're picking the one with the little x here, right? So what you're telling your calculator to do is put 4 in that spot. Okay? So your answer is 2. So R is 2. So we know that we're multiplying by 2 to get to the next one, right? So what's 20 times 2? Times 2? Times 2? Times 2? 320. So we know we're right. Now this one is basically the same question as the previous one, but we don't know the first blank. But they do tell us T2 and T5. So what did I tell you to do first off before you even attempt this question? Always. Yeah, write down your givens and draw it out with blanks. So blank, I don't know, 48, blank, then T3, T4, and then T5 is 162. Okay? What else did I tell you to do when it's this case and you're not giving the first and the last? Treat this as your little piece of information, right? So we're going to pretend that 48 is T1. We're going to pretend that 162 is Tn. What's the catch that everyone remembers to do that, but what do they forget? The number of terms is 4 in this case. So let's fill it out. Tn equals T1. Oops, I want to go back to the other formula. T1 times R to the n minus 1. And this shouldn't say A, it should say T1. Some textbooks you use A. A is also another word, another form for the first term, but we're using T1 because the textbook uses T1. The old textbook used to use A, so I need to fix that. So Tn is 162. T1 is 48. Times R, we don't know, to the 4 minus 1. Now, if you have to, put that in brackets, put that in brackets. If that's going to cause you to not put that exponent to the 48 as well, okay? Because this exponent only goes to the R, always. Divide by 48. What's 162 divided by 48? 3.3, is it a decimal or anything? So 3.375, does it stop there? Okay. If it doesn't stop there, you can't just write the decimal like 3 decimal places and stop. You'd be wrong, right? You're not going to get it accurately. If the decimal stops, you can use it. If the decimal doesn't stop, you'd reduce this fraction down and have to use multiplying by the fraction. Okay? If it wasn't a terminating decimal, which you say it is. It's 3.375 equals R to the 3. Now, what's 162 reduced? What's, 1 second. We could do it this way, which I would suggest you do it this way. Reduce this fraction. So I'm going to take, out of both of these, I'm going to take out 2. Okay? So I'm going to get 81 and 24. You could do that as well, right? You could reduce this to 81 and 24 and go that route as well. It will get you the same thing. Now we have to cube root our answer. The cube root button actually is math number 4. If you want to go that route, you can. But you can just cube root the decimal as well. So you can cube root that fraction, or you can cube root this decimal. And the only reason why we could write the decimal is because the decimal terminated, right? If the decimal was a repeating decimal, you couldn't just cut it off at 4 decimals and say, I'm good. You'd have to keep the fraction. Does that make sense? If not, you're rounding a decimal and you're not going to get the right answer. So R equals 1.5. So it's actually 1.5 to get from one to the next, right? You multiply by it. So I'm going to go 48 times 1.5. I'm just going to find the rest just to prove that I'm right. 72 times 1.5 is 108, and hopefully times 1.5 is 162. How do I work my way back to actual first term? You just divide. So 48 divided by 1.5, which is 32. Yeah. Well, the cube root of a fraction, if the fraction was a perfect cube, you could actually break them down. So say that the fraction was 27 over 8, let's say. If I took the cube root of that, the cube root of 27 is 3, and the cube root of 8 is 2. So then you just get another fraction. You would either do that or you use your calculator, yeah. Okay, so T1 is 32, and R is 1.5. I didn't actually need to find these other ones, but I wanted to find them to make sure I actually found the correct R, because that was the way I could check it, right? Okay. So here's a word problem. It says the value of the house increases by 4% each year. So every year it goes up by 4%. So R would actually be what? Yes, 0.04. The value of the house now is 5,000. So now it's 5,000. So what's that? 500,000. That is not 5,000. That's right now it's 500,000. So what? What is 500,000 representative of? T1. Would that be T1? Are you sure? So if we do, let's just try this out. If we say it is and we use the formula, okay, we would say that year 1 would be 1, we're saying, correct? So let's try it out. So T1, you're telling me, would equal, this is saying after year 1. So what is that actually? Is it T1? What is it? It's T0. That would be T0. That would be at no years, right? Yes, but if we were finding T1, it wouldn't be $500,000. It's the first term you're given, but you have to watch yourself. So when you're finding year 1, you're actually finding term. You're actually finding term 2. Yeah. That's what I'm saying. You'd have to treat it as 0 if you're going to treat this as T1. That's my point. But the formula doesn't have a T0 in it, does it? No. So we're going to treat this, my point is we're going to treat this as T1, but then year 1 would actually be what? T2. That's my point. My point is if you treat this, people want to treat this as 1, and then they want to treat year 1 as 1. You can't do that, right? Do you get what I'm saying? If you want to treat this as term 1, which is correct to treat it as term 1, because the formula doesn't have a term 0, does it? If you treat this as term 1, then people try and treat this as 1. So they'll say n is 1, because 1 year you would think would be 1, right? But it may be 1 year, but it's actually term 2. So this one you're finding term 2, and this one you're finding term 3. Does that make sense? Because you have to make this be term 1. I don't have a term 0 in my formula, do I? Okay? So does that make sense? So don't treat this as like n equals 1, which is what most people try and do. It's not n equals 1. This is when n equals 1. So this would be actually term 2. Does that make sense? So we're going to find term 2 for part 1. So it's going to be term 1, which is 500,000. R was 0.04, and then we're going to do 2 minus 1. Now, a lot of people will say, why don't we just times it by 0.04 and add it? Or times it by 1.04 and it gets you the total. You can, but what happens if I ask you after 8 years, right? Or 9 years? Then you're having to do it a whole bunch of times, which you could do essentially, but it's nice to use a formula. So this is going to be 500,000. Now, if we times it by just 0.04, which is what you're telling me, what are we going to get? A really small number. Is that true? The next year, is it worth that? No. So this is where people mess up. They'll put 0.04. Now, if your R is between 0 and 1, you're actually decreasing, right? You're taking less than 100% of that number, correct? So if you put in 0.04, which most people do in this case, you're going to get a really small number and you're going to move on because you're not going to think, hey, does this make sense? Because it really doesn't make sense. Your house went down like crazy amounts of value, right? So any R value between 0 and 1, you're actually decreasing. Is this decreasing? No, it says increase. So what you always have to do is make your R value be greater than 1 if it's increasing, okay? So in this case, your R is not 0.04, your R is 1.04, because the 1 represents 100% of the original value plus 0.04. If you don't put in the 1 for R, you're going to get a small number. We want 100% of our value plus 4% more. Yeah? You can, but it's going to cause you an issue when you start doing other terms. So we're going to treat this to 1.04. You have to, because this house is increasing by 4% per year. So you need 100% of the original value plus the 4% it's increasing. So this 1 actually represents 100% of the original value. Does that make sense? So if it's increasing, it needs to be more than 100%, which means it needs to be more than 1. So if you're putting 0.04, your value of your house is going to decrease. It just is. And that's not what it's going for. So we actually have to have 1.04 here. So it's 1.04 to the 1. Now that will include the 500,000, and you're not going to have to add the value to it. So what's 500,000 times 1.04? What do you get? Thank you. So that encompasses the increases as well, right? You're not having to add it to a total. So at 2 years, we're finding T3. Okay. So when we're finding this in 2 years, we're going to use T3. And so it's going to be 500,000 times 1.04 to the 3 minus 1, which is actually year 2. Yeah, good times. Love geometric sequences. They're fantastic. Next year we go to geometric equations because exponential functions, and the little 1 goes away. So what does this get you? 1.04 to the 2, because this is together, 1.04 to the 2 times 500,000. Nope. 1.04 to the 2 times 500,000. Oh, no, that was just for the... Oh. Yeah, 540. In this sequence, what is R? R is the rate of growth, right? R is your rate of growth. So R in this case is 1.04 because you're taking 100% of the original value plus the 4% increase. And that's how you're getting 104. But R is always in decimal form, so that's why you put 1.04. Yeah. What? That's fixed it. I was like, it shouldn't be direct because it should have been up a bit. So let's go to D. So remember when we're doing the years, we actually have to find the next term because term 1 is always year what? Term 1 is always year what? Year 0. So year 5 would be term. So you always have to remember you have to go one more term, right? Okay. So after how many years? This is where the years things comes into effect. So this is what I always think. This is how I do this. So this would be year 0. So my brain can work with this stuff. Year 0 is term 1. Year 1 is term 2. Year 3 is term 4. Year 10 would be term 11. Okay? Does that make sense? So when we solve this one out and find the term number, is that the year? No, it's actually what? One more than the year. Exactly. To find n. You can't because it's geometric sequences and that's the formula. Technically, yes. But you're not supposed to do it. Seriously. Okay. Okay. So this one says, after how many years will the house be worth at least 900,000? So 900,000 goes in where? T N, right? It's your last term. So we have 900,000, and initially it's worth 500,000. And then we do what? R, which was 1.04 to the n minus 1. We agree that's the formula for geometric sequences? So we divide by 500,000. So when we divide by 500,000, zeros cancel, and I'm left with 9 over 5 equals 1.04 to the n minus 1. What's 1.04? 1 second, in a fraction.
So you have to do a fraction then for this, or can you not just divide by it?
I'm going to show you how to do this with your calculator, which you're going to learn next year because it's a heck of a lot easier. So this is like a little advanced step because the only way you guys can solve for n in grade 11 is if you can make a common base. And you can't with this one. And I don't want to just ask you common base ones because that just sucks. So I'm going to show you how to do this with grade 12. Okay? With the calculator. Not with logs because that would make you sad. So if you were AP, I'd make you learn logs. So we're going to go y1, go to your calculator, and you're going to put 9/5 into your y1. So go to your y1 on your calculator if you have graphing one. If you don't have a graphing one, you're not being helped at this moment. You need a graphing one. So go into your y1. Yep. You're going to go just as a division. So you're going to go 9 divided by 5. That's how you make a fraction. So you go 9 divided by 5 in your y1. Okay. It'll be on here, and then I'll post it. Yeah. So in here, in your y equals, go 9 divided by 5. Okay. Everyone have that in their y1. Now in your y2, put this. In your y2, so in your y1, you have 9 divided by 5. In your y2, you're going to have 1.04 like this to the little exponent symbol, little hat symbol below the clear. And then in brackets, you're going to put x minus 1. There's an xt theta n button. It's xt theta n. It's below mode, I think. Yeah. And you're going to press that as x minus 1 in brackets. Okay? So in your y2, you're going to put 1.04, little exponent, x minus 1. Does everyone have that? And minus 1. Okay. Xt theta n button, this one here. The below mode. 1 close bracket. Yours is going to.
This one's supposed to look like.
Yep.
Okay. That's all I was wondering.
How do I see that one? There. There. Oh, good try.
Xt theta n.
There.
X
Okay.
minus
yeah,
1.
Minus 1.
Close bracket.
Close it.
Yep.
I got the 9 and the 5.
Then you're going to go bracket.
Bracket.
1.04.
1.04.
Close bracket.
Close the bracket.
To the exponent.
The exponent.
Open bracket.
Open.
X minus 1.
How do I put x? Oh. X
Minus 1 close bracket. Okay, now press in. This is just going to reset your calculator if someone made your window really crazy before. Go zoom, the middle top button, 6. And that will set your window back to, yeah, that will set your window back to 10, 10, 10, 10. Yeah. So you might have to go to your window, and can I see your, yeah. So go to your window and make your X max bigger than 10, because right now you're maxing out at T10. Make it be 30. Your X max, make it be 30, because your X is your number of terms. Okay, press graph and see if you can see where they cross. Can you see where they cross? We want to find out what that is. We want to find out what that value is. Graph. So we want to find out where that value is. So you're going to go second. Everyone's following along. You want to find out where that crossing is. So you're going to press the second button and then trace. And then you're going to find out where they intersect. So it's second, trace, and then you pick intersect. And then you just go enter, enter, enter. And your X value will tell you where. It's 15.98. So that would be actually 16, right? You'd have to round up. So N equals 16. So what year is that actually? 15.
15. Yeah. Okay. I was like, what? No.
No.
Wait, so then if you don't
You're 15. I won't be asking a ton like this. This is advanced.
do you have percentage fraction or can you not?
Yeah, but you need a graphing calculator. You need one. Yeah, like you need one. You can't not have one.
So can you not just do 900,000 divided by 900,000 and then work it out, or do you have to do 905?
You could do 900,000 over 500,000, but I don't know what the decimal is. And sometimes the decimal doesn't stop.
It was,
So then it's easier to do a fraction. Then you're fine.
and then you can work it out, and you get the same answer.
Yeah. But your Y1 would be 1.8 instead.
Yeah.
You still have to use your calculator.
So how would you do it then here?
Your Y1 would still be 1.8. You still have to do it that way.
Okay.
Instead of 9 over 5 in your Y1, you'd have 1.8.
But I mean, if you're doing it without your calculator,
You
how
can't.
would
No, because you guys have to use logs, and you don't know how to use logs. Logs is the 30 level.
using your calculator, how would you?
You would have to do logs, and you can't. It's a 30 level thing.
Oh,
So I couldn't ask you a rounded question like this without physically letting you use your calculator. I'll show you how to do one that isn't a crazy fraction like this, because there are ways you can do it by mathematics, only if I can make you get common base. But the moment I make you like not be able to get common base, which you don't know what that means right now, then you can't. Okay?
So, sorry, you're not going to ask it.
Not really. Not this advanced. I just wanted to show you, like not this question. The other ones, yes, but not, yeah.
Okay.
Okay, so I'm going to give you some questions to work on, and we'll finish the rest tomorrow. Yeah. So the first questions I asked in this word problem are fair game, though, right? Like being able to find those. Yeah.
Oh yeah.
Yeah. So page 39. Page 39. Page 39, 2C. 3A and C. Number 4. Number 5, B and C. We're going to do number 6, but not today. That's going to be the one we're going to find out how many terms there are, but I'm going to show you how to do it if you don't get something crazy like this. Okay? That'll be tomorrow. No, not for now. And then number 10. Number 10. So if you work hard, you should easily be able to finish this before the end of class. Okay? Easily. You're welcome.